Welcome to this video on parallel computing. I'm here to provide you with valuable insights. The voice you're hearing is AI generated, and this video is supported by the Norwegian Research Infrastructure Service. This involves collaboration between the universities of Bergen, Oslo, Tromsø, and NTNU, and working with Sigma 2 to manage the national e-infrastructure. Now let's explore the question, what is parallel computing? Parallel computing is a type of computation in which many calculations or processes are carried out simultaneously. The goal is to divide a larger task into smaller subtasks that can be solved concurrently, often improving overall performance and efficiency. Parallel computing can be implemented using parallel hardware architectures, such as multi-core processors, GPU accelerators, or distributed computing environments where tasks are executed on a Linux cluster. As a scientist, you probably want practical info about parallel computing. Let's start with the basic question: what's a Linux cluster? Linux clusters are powerful computer systems, especially designed for high-performance computing, HPC. In Norway, we have three main academic HPC systems: Saga, Fram, and Betsy. The Saga Linux cluster alone can handle around 140 million CPU hours each year. Now let's take a closer look at the Saga Linux cluster. We'll do this by logging in remotely through a terminal using SSH login. If you're not familiar with topics like terminal and remote login, check out the HPC onboarding videos on this YouTube channel. They cover various topics, and while I'll touch on some, my main focus is on parallel computing. The onboarding videos dive deeper into details, offering more explanations and practical examples. When you log into Saga remotely, the first things you'll notice are important info. There's a link to the online documentation site and info about the public Q&A. You'll find updates from the ops log, along with a link to its online version. Keep an eye out for important notices and warnings as well. The Saga Linux cluster comprises three essential components: the file system, the login nodes, and the compute nodes. There are 8 login and service nodes. For compute nodes, there are 7 different types, totaling 374 nodes. Take a look at my command line interface prompt when logging into Saga. This text string usually shows details like the username and host name. It's commonly called the command prompt, signaling that the Linux cluster is ready for your commands. Being aware of your location in the Linux cluster is important. It's similar to using coordinates to pinpoint a spot in space. The prompt reveals I've landed on login 3, one of the 8 login nodes on Saga. Think of it as the first coordinate on the Saga Linux cluster. Now my second coordinate is on the file system. 2 coordinates define my position in the Linux cluster: the login node, login 3, and the file system. To precisely determine where I am on the file system, I use the Linux command pwd, which stands for Print Working Directory. I type the command pwd into my prompt. This command is a small executable program located on the file system. When I execute it, it prints out my current working directory, and it uses a computing unit from the login 3 node to perform this task. Pressing enter after typing pwd reveals that my second coordinate is cluster home gimv, which is my home folder. The tilde symbol is representing my home folder. Therefore, my command prompt clearly displays both coordinates. The first is login 3, and the second is the tilde symbol, indicating my home folder on the file system. I can use another helpful command at my prompt, ls, with the L option. ls stands for List Directory Content, and the L option shows the content in a detailed, long format. Later, we'll see that many Linux commands come with one or more options. When I execute the ls command with the L option, it shows a list of directories within my home folder. This command is frequently used, so on the Saga Linux cluster, there's a shorter version or alias called ll. When you execute the ll command, it provides the same results as using the ls command with the L option. In fact, you can create your own short version or alias for any Linux command. We will discuss this in more detail later on. I can switch directories using the cd command, short for change directory. When I execute the command cdmxm, it shifts my location or moves my second coordinate into the mxm directory. You can see how this command changes my prompt. I'm aware that there's a Fortran program in this directory. It's called mxm_tmp.f90. So I can use the ll command on the Fortran program. To edit the Fortran program, I'll use the Emacs editor, but feel free to use any editor you prefer. I just need to write the Emacs command at my prompt, followed by the program name. By executing the Emacs command followed by the Fortran program name, the program appears in the terminal. This specific Fortran program is designed for matrix multiplication, the challenge we aim to address through parallel computing. More details about this Fortran program will be covered in our upcoming videos. There are two important keyboard commands for the Emacs editor. The crucial command is Ctrl-X followed by Ctrl-S. This saves any edits you make to the file. Another important command is Ctrl-X followed by Ctrl-C, which exits the Emacs editor, returning you to the terminal. For step-by-step tutorials on using editors to create and modify files, check out the HPC onboarding videos on our YouTube channel. These videos offer detailed explanations and practical examples on a range of topics. In this particular video, we demonstrate how to use the simple Nano editor. Before doing any parallel computing, I have to move from the login node and to one of the compute nodes. Let us first talk about the computing units on the compute nodes of the Saga Linux cluster. On the Sigma online documentation site, there's an overview of the nodes where we learn that normal compute nodes have either 40 or 52 cores. Additionally, there are 8 compute nodes equipped with 4 NVIDIA P100 GPUs and 2 CPUs with 24 cores. Now, you might find the terms CPU and GPU and cores a bit confusing. The computing units here are the CPU cores and GPU cores. It's worth noting that there are some inconsistencies in the use of the words CPU and core. In some contexts, CPU are the same as core. The historical reason behind this is that the CPU only had one core until 2005. On the online documentation site, you'll find more detailed information about the compute nodes. The normal compute nodes come with 2 Intel Xeon Gold CPU, some with the 6138 version featuring 20 cores, and others with the 6230R version having 26 cores. This means the normal compute nodes have 14,240 CPU cores. This is significantly more than the 8 login nodes, which only have 256 CPU cores. Additionally, the normal compute nodes have 192 gigabytes of memory. There are also 28 medium memory nodes with 40 CPU cores and 385 gigabytes of memory, as well as 8 Big Mem and 2 Huge Mem nodes with 3 terabytes and 6 terabytes of memory. The Axel nodes have 24 CPU cores and 4 NVIDIA P100 GPUs, with each having 3,584 GPU cores. The A100 nodes have 32 CPU cores and 6,912 GPU cores on each of the A100 GPUs. The total number of GPUs on Saga are 64 with 335,872 GPU cores. Going back to the topic of moving from the login nodes and to one of the compute nodes. This process is known as interactive jobs, but we'll cover this in our next video. I am looking forward to the next video. Wishing you all happy computing in the meantime.